Hello, this tutorial is about sequencing with interactive reinforcement learning. It follows on from a previous tutorial which was called a machine learning powered sequencer, which embedded a learning reinforcement agent into a custom language called rubber gosling. In this tutorial, what we do is take the stuff that ran in the background behind that language. So behind that language you didn't really need to see anything going on in the background. But actually, if you want to be a bit more creative and use your own sounds instead of being stuck with the sounds and sequences in that other language, then it's best that we can expose this model and the methods of communicating it to using the default language instead. Or you could make your own custom language to communicate with this script. So before we look at the text, just a quick zoom out to what's going on here. This script uses something called reinforcement learning. Reinforcement learning in the wider world of AI and machine learning has had some really big successes, like DeepMind's AlphaGo system. And in reinforcement we have some core concepts. We have an agent, and an agent explores an environment. When it explores an environment, it chooses actions to take. If its actions lead to a good result, it will get a reward. If its actions don't lead to a good result, it will receive a penalty. And over time, the agent interacts with the environment, making actions, receiving rewards and penalties, and adjusts and optimizes its behavior so it can function well in that environment. What we're doing in this tutorial is an interactive version of reinforcement learning in a musical context. So what's happening is the agent is living in the JavaScript window, and the agent's environment is some sequences that we send it from the audio engine. And what we do is we send it a pair of sequences. We have here the source and we have the target. And the agent listens to the source when it's learning and tries to match the target. So it tries to listen to one sequence and learn to play another sequence in response to it. So we show it pairs of sequences. And when it's learnt, what we do is we take away the teaching sequence but still give it the source sequence. And hopefully it should respond in the same way. So for example, in this tutorial we'll send in some kick drum and snare patterns, and we'll ask the agent to learn the snare and based on what it's hearing from the kick drum. And we'll show it a couple of combinations, and hopefully the agent will learn to play the snare based on what the kick drum is without hearing the snare anymore. So the sequences it's being sent are its environment. The agent also has some memory which we can configure, and the actual agent is a neural network which gets optimized over time. If when we're training it, if it plays the right beats, then it gets a reward. If it doesn't play the right beats, it gets a penalty. And the agent has two actions. It can either play a beat or it can not play a beat. So there's fairly simple outcomes from the agent. So let's have a look at this code. This code is what really runs in the background in the rubber gosling language. And we've got some extra things that you can play with. This script is designed so you don't need to get into depth about the reinforcement learning that's happening in the background. As long as you understand the concepts about agent and environment, then that's going to be fine. When we train the reinforcement learning agent, what we do is we keep a memory of its past inputs and corresponding actions. And we keep replaying kind of random samples from this memory in order to train it. And it slowly learns over time from kind of revisiting its past actions. In the script then you can configure the size of this memory. So at the moment it's set to 128. If you wanted it to learn kind of lots of behaviors at once, you might want to make this number larger, although it will take a bit longer to learn if you do that, to pick up new behaviors, because it will always be learning from a mixture of its past behaviors. And then this other variable here, replay size, lets us choose the size of the random sample we take from the bigger history of actions each time we train the network. This beat count variable should always be the same as this beat count variable here. This is a clock that governs how these two windows share beats. The agent has a memory of the source material that it's hearing, and you can configure the size of this. 1 is fine if it just remembers the current beat that it's hearing. You could make this much longer, in which case the agent will take longer to change behavior based on new input. So you might get some more interesting behaviors if you have a longer number here, though it won't be quite as responsive as it could be. The agent also has its own short-term memory of its past actions, and by default this is set to 0, but you can set this to any number you want, and in which case it will base its current action, its decision for the current action, not only based on what it's hearing from the source, but what it's done in the past. So you could get some interesting effects from messing around with that variable. Let's now have a look at this live coding script here. This is pretty much what's going on in the background in Robert Gosling, and some of these sections of code have been commented or marked as do not edit. So basically they kind of manage the communications and sequencing between the audio engine and the machine learning model, and it's a little bit complex. It's probably best to leave these sections of code alone. So there's one here, there's another one here, and there's one right at the end, and they have to go in that order, I think. But in between you can do your own thing. So the workflow here really is, you can set the BPM, and there's a mode. This mode button's really important. If it's set to 0, so we change this mode by changing the number, then evaluating the live code. If it's set to 0, then the model will be learning from the sequences we're sending it. If it's set to 1, then it will be predicting, and if it's 2, it's just off. So we're not sending anything to the agent, and we're ignoring what it sends to us. So you can just live code as normal in that case. Then we've got two sequences. This sequence here is the source sequence, and it's paired with this target sequence. We want the agent to learn how to play this based on what it's listening to here. Then there's a bit of code that we shouldn't edit, and the last bit is signing the sequences to sounds. So we've got this source variable and the target sequence variable, which actually gets turned into this sequence variable here. So what this bit of code does is, if we're learning or the sequence is off, we use our target sequence. If we're predicting, then it brings in the signal from the neural network instead. So we're kind of funneling information into this sequence variable. And then you can choose the sounds here. So at the moment we've got a kind of kick drum and a snare-ish type sound, and then everything gets mixed together. The advantage then of having this in the default language is that you can go and add your own stuff, and you can be much more flexible with how the sequencing works. The limitation is that it's all quantized to a clock. So this beat count, if it's set to 8, everything will get binned into 8 periods during one bar. You can set it higher as well, or you can set it lower as well. So you could try 4 or 16. Just remember to match it with this beat count variable here. Let's take a look at how this script works. I'm going to teach this agent two pairs of different patterns and see how it responds. First of all, I'm going to initialize the agent. So we've got a replay memory of 128, so that's kind of medium sized maybe compared to the beat count. It's just listening to the previous beat, and it doesn't have its own short-term memory. We'll keep things really simple for this tutorial. And I'm going to put it straight in predicting mode, which means we're going to listen to what the randomly initialized agent does. I'm going to send it 4 beats per bar of a kick drum. Let's try and teach it something then. I'm going to try and teach it this pattern. We could listen to this pattern by just switching the machine learning off. If I switch it into learning mode, then we'll look at the loss in the console and wait till it goes down a bit and then see how well the agent has picked up the pattern. Slowly getting there. Let's have a listen to the prediction to see how well it's done so far. Well, it's starting to sound a bit like that pattern. Let's learn a bit more. Okay, let's listen again. Now it's learnt the pattern. Let's teach it another pattern. I'm going to switch this to off so that we can just hear the raw sequencing. And let's teach it another snare pattern to pair up with 8 kick drums per bar. So why don't we teach it something simple just to do 8 snares per bar as well. Let's switch it to learning. Now let's listen back to predicting. So it seems to have picked up that pattern as well. But the question is, what happens if I switch between 8 and 4 here? Does it remember how to do the original snare pattern in response to 4 kicks per bar instead of 8? Let's have a look. We've got some successful training there. So the agent has learned to respond to do 2 different source patterns and give 2 different snare patterns in response to those source patterns. And the idea is you can just carry on training this agent with different patterns. Sometimes you might train it too far and it will forget what it's learned already. Sometimes you might train it too little and it won't pick something up. Sometimes you'll get some nice surprises. Sometimes it might be disappointing because it doesn't work very well. But keep persisting. Training neural networks is a bit like doing a performance with them. So the materials that you show to the network and the order in which you show them and the amount of time in which you show to the network, these are all factors in how the network learns. So you can think of it as a bit like improvising with a machine learning partner and teaching them kind of slowly some different musical behaviors. Sometimes it will go well, sometimes it won't. Hopefully it will be fun.